Hello everybody, welcome to my channel How to Solve Physics. Physics is a natural science. To learn, try to associate with nature. Let me explain. To discuss horizontal projectile, you have to come with me in nature, not in a closed classroom. Then what's for waiting for? Look, flight of the beautiful bird, and notice landing of the bird on the ground. One more time. What you have been noticed? Bird give itself a constant velocity in the forward direction and remaining the gravity pull it downward and there is a flight. Here we are not discussing the aerodynamics. That's the matter. Further we will discuss. And there is a horizontal projectile of the bird. Take one more example of landing a flight. Say a flight is moving horizontally with constant velocity along x-axis. Say u is the velocity with which it is moving. Say it is y-axis in which acceleration due to gravity is there. Look at closely the landing of the flight. If an object which is known as projectile, say toy aeroplane, is given some initial velocity from an altitude which is represented along the y-axis here is, and it is free to move. Nothing you have to add. In a gravitational field or any other, say electric field, it is who is object is known as horizontal projectile. And its motion is known as horizontal projectile motion. Now we will discuss physics of the horizontal projectile. Say this is the toy aeroplane for which we are discussing, which is moving horizontally with the initial velocity u along x-axis. This is y-axis. Initial velocity u, which is acting horizontally in x-axis, is pulling the aeroplane in forward direction, whereas acceleration due to gravity along the y-axis pull it in the downward direction. Now we will discuss the physics of the horizontal projectile. First of all, the position of the flight at the different time instants. We will discuss the two coordinates along the x-axis and along the y-axis. Say P is the point at any instant of the time t of this flight. X is the distance from the origin along the x-axis. Y is the distance of the point P along the y-axis. Along x-axis, first of all, we will use the second equation of motion that we already discussed in kinematics. X equal to x naught plus uxt plus half ax t square. As far as x naught is concerned, x naught, you can check, we started from the origin, that's why this x naught is nothing but 0, isn't it? As far as the ux is concerned, means the initial velocity along the x-axis, that is u. As far as the ax is concerned, ax along the x-axis, you just check it out, there is no acceleration, only the velocity. That's why ax is nothing but how much? 0. Now we can substitute the values here. X equal to 0 plus ut plus half 0 multiplied by t square. What we are getting? Ut only, means x equal to ut or t equal to x by u. We can say this is first equation. Now we are ready to discuss the position of the flight along the y-axis. Along y-axis, we again use the second equation of motion, y equal to y naught plus uyt plus half ayt square. What about this y naught? Again you can check it out. Y naught is again 0 because we started from origin. As far as the uy is concerned, uy, you can check yourself. We are not given any initial velocity along the y-axis, that's why uy here is 0. Is it? As far as the ay is concerned, means acceleration along the y-axis, of course there is acceleration, you know, in downward direction, and which is nothing but the g. Is it? Yes. We can substitute the values. Acceleration ay is g here, y equal to 0 plus uy is 0, 0 multiplied by t plus half plus g multiplied by t square. Y plus g, actually downward direction, the y-axis we are taking here is the positive. We can sort it out, y equal to half gt square. In first equation we are having the value of the t, we can substitute it here. Substituting value of t in equation second, what we are getting? Y equal to half g, t is how much? X by u, that's why whole of a square. If you solve, we are getting y equal to g by 2u square multiplied by x square. This is the final equation of the trajectory, means we can decide the path from this equation. Equation y equal to g by 2u square x square is in the form y equal to kx square. Here this g by 2u square, that is within the bracket we are taking the k. Okay, means variable is only x and y, that's why the equation is in the form y equal to kx square, which is equation of a parabola. Thus trajectory means the path of a horizontal projectile is what? Parabola. Is it? Yes. Now we are in the position to solve a numerical problem on horizontal projectile. Let's take a helicopter is moving uniformly with 1260 km per hour horizontally. You can take it's the x-axis at an altitude, that is from the ground, of 1000 meter. At some instant, a bomb is dropped from helicopter during its motion. It is just hit a target on earth. How far, what we have to find, how far was the target on the ground from the position of the helicopter when it has been dropped. Let's try to solve it. Take observation during the release of bomb from helicopter concern in the problem. What you have been noticed, just before releasing the bomb, the helicopter is moving uniformly. Therefore, due to the inertia of motion, the initial speed of the bomb is equal to the speed of the helicopter and is in the same direction. That's why the initial speed pull the bomb in forward direction, and as far as the acceleration due to gravity, that pull the bomb in downward direction, and it may strike the target. Using these observation, we will solve the problem. Bomb is following a horizontal projectile motion. That's why we can use the equation of trajectory. We know equation of trajectory of horizontal projectile is y equal to g divided by 2u square multiplied by x square. We are having some values. Y means the height, g by 2u square, x is nothing but r. Here is x is r, we're taking here r in general known as the range. H, this h is the height of the helicopter from the target. Now we are going to substitute the values. If you want to solve for r square, it is 2u square h divided by g, means r is nothing but we taking the square root both side, that's why we are getting u square root of 2h by g. Here u is 350 meter per second. Why it is? We have to convert the 1260 km per hour into meter per second. Do you know how it is? Kilometer, 1 kilometer per hour means 1 kilometer is having 1000 meter. Is it? This meter. Hour is 3600 seconds. Is it? These are seconds. Two zeros and 20 we can cancel out, right? With help of the table of the 2, it is 5, it is 18, means there is a handy rule. If we want to convert 1 kilometer per hour into meter per second, you just multiply by 5 by 18, means 1260. 1260 multiply by, which is a conversion factor, 5 by 18. What you are getting? 350. Okay, now it's clear how the 350 comes out. Okay, fine. H, that's given in the problem in the meter, the 1000, and G is the 9.8. Now we can solve further. 350 multiply by 2. From 2 we can cancel out the 9.8. How? Look, if we remove this decimal, we are having the 10 in the square root. Is it? Okay. From 2 we can cancel out, it is 49. Is it? Yes. Now in the numerator the 10,000. Yes. And the denominator 49. Now easily we can take the square root of the 10,000 is the 100, and 49 everybody you know the 7. Now it's clear. Okay, we further solve it out. 7 5s 35, means the 50 multiplied by 100. What we are getting? The 5000 meter, and you know the 1000 meter is 1 kilometer. That's why R is equal to the 5 kilometer. That's the answer. Your problem solved. Thanks for watching. See you in next video, which is on circular motion. Till then, stay tuned with me. With subscribe now. Share with your friends. And 1.